kind of look at it together here first to start with. Up to this point, you've looked at functions with periods that are just the usual 2 pi, and actually the warm-up questions that I just gave you didn't even have any period change at all. If you put a number in front of, if you put a number in here, multiply that. So if you change from sine x to sine of b times x, you know that from transformations that causes a horizontal expansion or compression. If you change y equals f of x to y equals f of b times x, it causes a horizontal expansion or compression. Think about how that change happens and what kind of numbers cause what kind of change here. If you change something to say 2f of 2x, what kind of a change does that cause from f of x? Horizontal compression by a half, right? Kind of works in the opposite here. Any values you had on the original function are now going to be half as much x values. If you change to y equals f of a half x, it causes horizontal expansion by 2. It works in the opposite way. Applied to this now, if you have just the usual thing here, sine x, or of course you could write it as sine of 1x. The period is just 2 pi, right? That's our starting point. You really have to think of this as the starting point for the period. Sort of that's the usual period. And then anything else is changed relative to that. If the period is going to be pi, what number has to go in here? Well, the period is half as much, right? So what number has to go in here? Has to be a 2. If you want the period to be half as much, you need to put a 2 in there, right? Just think of it as this, that you start with 2 pi. If you put a 2 in here, the period is going to be divided by that number. Okay, the period is 2 pi divided by 2. If the b value is 2, the period is pi. You could look at this as 2 pi over 2, right? 2 pi divided by 2, if you really want to, the way it says here. What about if the period was 2 pi divided by 3? What number has to go in here? Y equals sine of, what is it? 3x, right? If you put a 3 in there, you take the usual period and divide it by 3, right? You're compressing it. Visually, it looks like, let's go up here for a second, not to use that GeoGebra, I know how some of you feel about it. If we have a set of axes here, and here's your sine graph, I'll draw it as best I can. There's just one cycle of that. Actually, we should draw more than one cycle. Let's draw more than one cycle. This is really bad. Okay, this is really poorly drawn, but there's more or less there's 3 cycles, right? This is 2 pi, right? Normally that's 2 pi. If you put a 2 in front of it, it's going to move that now. There we go. If you put a 2 in front of it, it's going to compress this so that 2 cycles are in 2 pi instead of 1 cycle, right? 2 cycles are in 2 pi, not 1. Right? So this point here, this point right here is going to move so that, just think about where that point goes here. Okay, so that point goes to there. 2 cycles in 2 pi. If you change it so that you have a 3 in the equation, 3 cycles are going to be in 2 pi, right? Or each one is going to be 2 pi divided by 3, right? If you change it to that, each one of these cycles, once you compress it, you can see how badly drawn it is. Whatever was this full thing before now is now compressed into that, right? It's compressed by a third. So if the period normally is that, and you put a 3 in there, it's 2 pi divided by 3. Whatever number is in there, this is a 3. if you have this, as long as you can see the period as 2 pi divided by something, you can see what that number is, right? If you can write this as 2 pi, pi over 4 is the same as 2 pi divided by 8, so that means the b value is 8. Right? If you have a period of 2 pi over 23, what would that function be? Sine of 23, right? 23x. If you can write it as 2 pi over something, that's the b value. Okay? That b value is what's underneath that 2 pi there. Now the change in this is what we did in 4.2, part A. This is 4.2, part B. If you want the period to be a nice number, let's label these here. These are not so nice numbers. These are nice numbers. These are going to be nice numbers down here. When the period was not such a nice number, the b value was a nice number. Okay? In other words, when the b value did not involve pi, the period involves pi. Just because that's the way the function works, right? If you want to scale it so that the period does not involve pi, and let me skip ahead here to show you what I mean. If you look at some of the graphs involved here, these are pretty tiny little numbers as far as this, but the scale here is rational numbers, nice numbers, not fractions of pi. All of these graphs have rational numbers here, integers. Whereas the things in part A, the period and the scale and the graph was always pi fractions and stuff. If I want the period to be 2, could I write this in my same way here as 2 pi over something? Can I write it as 2 pi over something? How can I get it to be a 2? If I put a pi in the equation, if you put a pi in the equation, it's going to make it so that the period is a rational number now. In other words, if you write this as y equals sine of pi x, if that's pi, the b value is pi, then the period is going to turn out to be something that is rational. Because you're dividing by that. You're scaling it by pi, right? If you looked at your original thing here and looked at if I asked you the question then, okay, if you look at that question there, if I had said, what's f of pi times x? If you put a pi in there, what is that going to be a compression by here? This is really weird. What's that going to be? Sorry, I got to write it again. F of pi x, what's that going to be? Horizontal compression by what? 1 over pi, right? Not a half, by 1 over pi, right? You're dividing whatever the x values are by pi. So whatever the period is normally, which is 2 pi, it's going to be divided by pi. If you want the period to be 1, what number do you have to put in there? 2 pi. To work backwards here, if the b value is 2 pi over 11, what's the period here? It's just 11, right? That relationship works the same way. As long as you can, if you look at one of them as 2 pi over something, the other one is just the something on the bottom. Okay? If we can write this, and this is why this is written here like this with a p on the bottom here. This is just the period. If it says 2 pi over p as the b value, this is just the period on the bottom here. Okay, the rest of this is for you to kind of work through here and think about this. This kind of little formula you could write. If you like formulas, you could write the period of a function is 2 pi divided by whatever that value is, whatever b is, right? Period is 2 pi divided by b, or b is 2 pi divided by the period. Or you could say that the two of the things have to multiply to 2 pi. b times the period has to multiply to 2 pi. Just like any other formula, if you say that a is equal to b times c, you could write it as b is a over c, or you could write it as c is a over b. There's 3 ways to write that same formula. All right. Look back at this table we have here. If you look at these things, that multiplies to 2 pi. If we erase all of this stuff here. Oops. All of these things, that multiplies to 2 pi. This multiplies to 2 pi. This multiplies to 2 pi. All of these things, they all multiply to 2 pi. Okay? That makes sense? All right. Can we work through this, please, then? And we'll kind of look back at it maybe at the end, make sure we're okay.